Hello everyone, welcome back to the video lecture series on geotechnical engineering with me Nihal Naveen. So today we are going to start one of the most important topics from GATE point of view, and that is shallow foundation. This will be the base for foundation engineering, okay? So just focus on all the videos of this topic, okay? So let's begin shallow foundation. Now what is foundation? Foundation is actually that part of the substructure through which load of superstructure is transferred. Now let's first see what is substructure and what is superstructure. Okay? Substructure is actually that part of the structure which lies below the ground level. For example, let's take this figure of a structure. All these are the floors, okay? And we have the foundation. Both these are the foundation, okay? And let this be the ground level. Now whatever part which is lying above the ground level, that is this portion, this is known as superstructure. And the part which lies below, that is the basement area or the foundation, that comes in the substructure. Okay? And this part, this is the foundation, which is used to transfer the load of superstructure to the ground. Okay? So let's see the types of foundation then. There are two types basically. First is the shallow foundation and the second is the deep foundation. Now this shallow foundation, it may be defined both by Terzaghi and Skempton. According to Terzaghi, if depth of foundation is less than breadth of foundation, then it is considered as shallow foundation. And according to Skempton, if depth of foundation is less than 2.5 times of width of foundation, it is a shallow foundation. Similarly, for deep foundation, like the well foundation or pile foundation, we have if the depth is greater than breadth, according to Terzaghi, it is a deep foundation, and if the depth is greater than 2.5 times of breadth, it is a deep foundation according to Skempton. So both these scientists have given their different views regarding the types of foundation. Okay, you have to just remember. So let's see types of shallow foundations first, and we will be covering the deep foundations in the coming videos. Actually, foundation we will cover in two, that is, first is shallow foundation. Here we will be studying the concept of bearing capacity and bearing pressure, and in deep foundation we will be studying about the pile. Okay, so the first is the raft or mat foundation. Okay, now let's see this figure. This is a raft or mat foundation. Now it consists of a reinforced thick concrete slab. Actually, this is the concrete slab, as you can see, and above this we have this is the wall, okay, and these are the columns. These are the columns. This is the wall, and these rising structure are the columns. Now this is used to support the columns and the walls, okay, and generally used in soil which is weak or loose, and generally it may be sand. So you have to remember this soil is used for weak, and as I told, it consists of a thick concrete slab which actually transfers the whole load of the superstructure over a larger area. Okay, so the area becomes large, effective area becomes large, and naturally so it is used for weak soil. Okay, the second is the isolated footing. Now isolated, as the name suggests, it is used for single column, that is a separate column. Now isolated footing may be of different types. It may be either square footing, this is the square footing, okay, this is the rectangular footing, and this is the circular isolated footing. Okay, you can see this is the B is the width, this is the actually depth of foundation, df, which is denoted by df, and actually this is the cross section. You can see the top view, B and B both are same, so it is a square actually. And here B1 and B2 are different, so length and width are different, so it is rectangular. And in circular, generally you have the diameter as B. Okay, so this is the isolated footing. The third type of footing is strip or continuous footing. Okay, and the Terzaghis theory, which you are going to study in the next part, that is basically based on strip or continuous footing only. The concept of ultimate bearing capacity. Now this is commonly used as foundation for load bearing walls. Now this is a load bearing wall and this is the foundation. Okay, so this is a reinforced concrete strip footing, as you can see, and here you can see this is the length actually, L, and this is the width, that is B. So L here is much greater than compared to B, so it is considered continuous in a X direction, you may say, if this is the X direction. Okay, this is the Y and this is the Z. Okay, so it forms a part of strip or continuous footing. Now another type of footing we can see, that is strap or cantilever footing. Now here two columns are attached by a strap beam. Okay, this is the strap beam and two types of column, as you can see, and this is also known as tie beam. Okay, and it is used to prevent the differential settlement. Okay, that is, there must not be any difference in the settlement of both these columns, that is, both these columns have to settle the same depth. Okay, now let's see, it is a type of combined footing. As I told, two columns are present, consist of two or more column footings connected by a concrete beam, that is known as strap beam. Okay, now the fifth type of footing is combined footing. Now combined footing, they may be either rectangular or trapezoidal in nature, and generally they are constructed due to space limitations. Where you have constricted space, there you use the combined footing. Okay, you can see the figure. This is the rectangular combined footing and this is the trapezoidal combined footing. Okay, you can see the top view. Now there are two types of failure that occur in foundation. Okay, you have to remember this. The first is the shear failure and the other is the settlement failure. Okay, and for design purpose, minimum of two safe loads that occur in shear as well as settlement, we have to consider the minimum safe load. Okay, that will be the design load. Okay, so let's see, when load supporting power of soil is less than structural load, then this shear failure occurs. Okay, when the power of soil, shear strength of the soil is less than the load which is transferred. And here the term bearing capacity is used in case of shear failure. This you have to remember the difference. In case of shear failure you use bearing capacity, and in case of settlement failure you use bearing pressure. Okay, and settlement failure, it occurs when settlement in soil exceeds a permissible or tolerance limit. So this settlement in soil has to be below this tolerance limit. Okay, it must not exceed that value. And safe load, you can say as safe load in case of shear failure, it will be, as I told, in case of shear failure you have to use bearing capacity. So bearing capacity into footing area, you will get the load. This will be in meter square footing area and this will be in kilonewton per meter square. So you will get the final value in kilonewton. Now in case of settlement failure, safe load, okay, safe load in settlement failure, what we have the value, it will be bearing pressure. Okay, bearing pressure into footing area, and this value also will get in kilonewton. Okay, so moving on to the next, let's see some of the basic definitions, that is very important. And for understanding this foundation chapter easily, you have to first go through the concept of effective stress, okay, and total stress, and also pore water pressure, and these I have already covered in the previous video. You can just go through and clarify all your doubts. It will be very clear to you, and then you will easily get all these foundation concept. Okay, so let's see some of the basic definitions which will be generally asked in question. Now first is the gross pressure intensity, that is denoted by QG. Now just see the notations and remember them. Gross pressure intensity. Now what is gross? You know that it is actually the total weight. So actually the total pressure at the base level of foundation. Now this gross pressure intensity, it may be either due to the self weight of footing, okay, due to applied load that is being applied, okay, and the self weight of soil above the foundation level. Now let's see this foundation. okay. Let B be the width of foundation, okay, and this is actually the depth of foundation denoted by df, and this is actually the ground level, and this we have the foundation, and load is being applied from like Q, okay. So gross pressure intensity, it is due to self weight of footing, that is this weight of self weight of footing, okay. If it is made of concrete, then we will take the unit weight of concrete, okay, and then due to applied load, this is the applied load, that is Q, and next we have self weight of soil which is present above the foundation level. Now this is the foundation level, that is depth of foundation, actually the length from depth from ground level to foundation level, this is the foundation level, okay. The soil which is present above this foundation, that is this soil, that weight also you have to consider in gross pressure intensity. Now coming to the next important definition, that is net pressure intensity. First we studied the gross pressure intensity and next net pressure intensity. Net pressure, what does it mean? It is actually the pressure which is exerted in excess of initial effective overburden pressure, okay. So that will be gross pressure minus effective stress. So Qn is, it is noted by Qn, okay. Just remember this. Qg, you have already studied what is Qg, minus effective stress, that is denoted by sigma dash, okay. So this is actually gamma df. You have studied about this. Gamma is the unit weight of soil and df is the depth of foundation up to foundation level. Now this gamma may actually be, it may be dry or bulk if the soil is dry, and it may be, this gamma may be either gamma dry or bulk, and if it is submerged state, then you have to take gamma submerged, okay, gamma submerged. So it just depends on the conditions which is given in the question. So net pressure intensity is gross intensity minus effective stress. And the third is ultimate bearing capacity. Now bearing capacity term is coming, so it is related to shear failure. So it is actually the minimum gross pressure at which the soil just fails in shear. So just remember, the soil just fails in shear, that is that minimum gross pressure is termed as ultimate bearing capacity, that is denoted by Qu, okay. Now moving on to the next definition, that is the net ultimate bearing capacity. Now again the term net is coming, so this net ultimate bearing capacity will be the net pressure in excess to initial overburden pressure, the same as net bearing pressure that we have studied before. So it will be Qn denoted by Qnu, that is net ultimate, is equal to Qu minus effective stress. So here also Qu minus sigma bar, that is effective stress, Qu minus gamma df. Now this gamma may be either submerged or gamma bulk. Now the fifth definition is net safe bearing capacity. Now here both the term net as well as safe is coming. Now where safe is coming, you have to use factor of safety, okay. It is denoted by Qns. Now it is actually the ratio of net ultimate bearing capacity, that is Qnu, to the factor of safety. Now this factor of safety will be given, we have to take either 3, 4, 5, whatever value is given, you have to take it. Now Qns is equal to Qnu, that is Q net ultimate divided by factor of safety. Now Q net ultimate can be written as Q ultimate minus effective stress. So the final formula you have this. So in question if it is asked, just follow these steps and get it. Now the sixth and the most important, which is generally asked in the questions, this is the safe bearing capacity denoted by Q safe. Here the net word is missing here, okay. So it is actually the maximum gross pressure which can be applied at the base safely without shear failure. So it is actually the maximum gross pressure and not the net pressure. So what we have to do here, Q safe is equal to Q net safe bearing capacity plus we have to add the effective stress here because it is a gross pressure, okay. So net safe we can just convert it into net ultimate and finally ultimate. So Q safe is equal to Q net safe is actually Q net ultimate by factor of safety plus sigma effective, and finally we can write Q net ultimate as Q ultimate minus effective stress, and we will finally get the value as this, okay. Just you see that, just make a note here that factor of safety is not applied to initial overburden pressure of soil, okay. This initial overburden pressure we are not dividing it by factor of safety. Why? Because this pressure has been exerted through historical times, okay, and this value has not changed. So we don't need the value of factor of safety here. Okay, so just we will use sigma effective, that is initial effective overburden pressure. Okay, just remember this. This is generally asked in the questions. Now let's take a look at some of the factors which affect the bearing capacity. Now the first factor is the type of soil and its properties. Okay, that is the cohesion property, the angle of internal friction, okay, the unit weight of soil. All these factors will affect the bearing capacity. The second is the type of foundation. Okay, that is if either it is a rectangular foundation, a strip foundation, circular foundation and square foundation. We all have different formulas for finding the bearing capacity. Okay, so it will also depend on the dimensions of the foundation as well as the types of foundation. Now the third will be the location of groundwater table. Now this groundwater table actually affects hugely the bearing capacity value. Okay, there will be a separate video for this, how this groundwater table actually affects the bearing capacity. Okay, so just focus on this video, that videos, to clear your concepts. Now the fourth factor is the size of foundation, that I have already mentioned the dimensions, that is width or depth, and the value changes, bearing capacity value. For your clear info, I am giving actually the bearing capacity value, that is Q ultimate is given as CNC plus QNQ plus half gamma BN gamma. Okay, this you will be studying, this actually given by Terzaghi to find the ultimate bearing capacity of soil, that is QU, and it depends on different factors, that is NC, NQ and N gamma are the bearing capacity factors, and C we have the value of cohesion, and Q is actually gamma into dF, that is the net overburden pressure which is acting. So you can just see that it depends on, and B is the width of foundation. Okay, so you can see it is depending on the width as well as depth. Q is actually gamma into dF, so it depends on depth as well. Okay, this formula you will be studying in great detail in the next video. Now it also depends on nature and type of loading, that is whether it is the load is concentric or it is being acted at a part away from the center, that is either it is eccentric. Okay, so the values will change accordingly. And the next factor is initial stress condition of the soil, that is whether it is over consolidated or normally consolidated, and the values will change. Okay, and the last is the mode of shear failure which is taking place, that is either the general shear failure, local shear failure or the punching shear failure. Now all these type of shear failures you will be studying in the next video. We will begin with this only, so you will have a clear understanding. Okay, so we come to the end of this video. Hope you enjoyed it. In the upcoming video we will be starting with the different types of shear failure. Okay, that is general shear, the local shear and the punching shear, and we will also be seeing the different analytical and field methods for finding the bearing capacity value. So you can also practice free quizzes at Grade Up and always be a grade higher, and do watch the next video. Okay, all the best and thank you.